Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. If you can remember and recollect, in the previous class we had elaboratively discussed process synchronization, where we had focused on the use of a shared variable known as semaphores for coordinating the operations of various cooperating business processes. We also discussed the significance of the two functions defined on the semaphores, wait and signal. Then we moved on to some of the notable advantages and disadvantages of semaphores. Moving ahead, in today's class, we will discuss another important concept in operating system that is called as critical section. Critical section is a piece of code in a business process using which it manipulates the shared resources. Again, I'll repeat it. Critical section is a piece of code in a business process using which it manipulates shared resources. Shared resources, for an example, may be either a simple variable or it may be either a composite variable like tables and files. So here we have a process P1 with its critical section CS. As learned and understood in the previous class, a typical computer system may have in it several cooperating processes. These cooperating processes may be wanting to manipulate these shared resources. Therefore, it is very important for us to have a well-defined synchronization mechanism put in place for facilitating ease of coordination and for ensuring consistency and integrity of shared resources. So here we have n number of processes P1 to Pn in a computer system wanting to manipulate the shared resources. Now, one fundamental principle on which execution of critical section of a process depends on is when one process is executing its critical section, no other process should execute its critical section. So this is the fundamental principle on which execution of critical section relies on. So when one process is executing its critical section, no other process should be allowed to execute its critical section, implying no two processes should execute the critical section at the same point in time. Now let us try and understand what critical section problem is. The critical section problem is to develop a synchronization mechanism for enabling cooperating processes coordinate with each other in order to perform operations, ensuring data consistency and integrity. So the critical section problem is to develop a mechanism to enable cooperating processes coordinate with each other to perform operations, ensuring data consistency and data integrity. Now it is implied that any process that is desiring to enter the critical section should first request for the same. So any process desiring to execute its critical section should be first tested for ensuring whether it should or it should not be allowed to execute its critical section. Keeping these constraints in mind, the very organization of a business process should look like this. The organization of a business process should have in it the entry section, it should have in it the critical section, it should have in it the exit section, and it should have in it the remainder section. Entry section is a section that validates whether a process should be allowed to enter into its critical section or not. Once a process is allowed to enter into its critical section, it will execute its critical section, and eventually there should be a section that allows the process to exit from its critical section. So that is called as exit section. And process should have remainder section. So remainder section is a section in the process that is other than the critical section, which allows the process to perform some business. So other than critical section, any business performing portion of the cooperating process is placed in the remainder section. So this is the way how a business process is to be organized. It has to have an entry section, it has to have critical section, it has to have exit section, and it has to have remainder section. Now here it is to be understood that the entry section and the exit section should work on a shared variable known as semaphore, because semaphore, as learned, is used in order to facilitate synchronization of various cooperating processes in a computer system. So entry section and exit section should work on the value of semaphore to enable a business process perform its critical section. So the very organization of the code of a business process should be, it should be entry section first, that validates whether the process should be allowed to enter its critical section or not, then critical section, then exit section, and then the remainder section. Now let us go through the rules for critical section. The first rule for critical section is called as mutual exclusion. Mutual exclusion implies no or not more than one process can execute its critical section at one time, which implies no two processes can execute its critical section at the same time. So not more than one process can execute its critical section at one time. So mutual exclusion is a special type of binary semaphore which is used for controlling access to the shared resources. The second rule of critical section is the progress. This solution is used when no one is in its critical section and someone is desiring to enter into a critical section. So when none of the processes in a computer system is executing its critical section and all of them are desiring to enter into its critical section, then those processes that are not in their remainder section should decide on who should enter into the critical section within a finite time. So this is what progress implies. So if there exists no business process in its critical section and all of them are desiring to enter into its critical section, then those processes who are not executing its remainder section should decide on who should enter into its critical section within a finite period of time. Now the third rule of critical section is bounding wait. When a process makes a request for getting into its critical section, there is a specific limit about the number of times other processes can get into its critical section. So when the limit is reached, the system must allow the requesting process to get into its critical section. So again I'll repeat it. So when a process makes a request to get into its critical section, then there should be a specific limit on the number of times other processes are allowed to get into its critical section. So when the limit is reached, then the system must allow the requesting process to get into its critical section. Now this is done in order to prevent a process from starvation. So a process should not be allowed to wait for infinite time in order to get into a critical section. So these are some of the important rules for critical section. So in today's class, what we have learned about is what is a critical section. We have learned that critical section is a piece of code in a process using which it manipulates the shared resources. We have learned that in a computer system there might be several such cooperating business processes wanting to enter into critical section, wanting to manipulate the shared resources. So there has to be a proper synchronization mechanism in place for facilitating ease of coordination and ensuring consistency and integrity of shared resources. Then we came across the basic principle of critical section execution, and then we discussed the critical section problem, where we discussed on the way how the organization of the business process should be done. So the very organization of the business process should have entry section, critical section, it should have exit section, and it should have remainder section. Then we discussed a very simple programming construct for the same, and then we moved on to the rules of critical section, where we discussed mutual exclusion, we discussed progress, we discussed bounding weight. So we'll end our class here, and in the next class we will be discussing some of the popular problems in critical section, that is producer-consumer problem, reader-writer problem, and dining philosopher's problem. Till then, thank you very much. Have a very good day.